Hello friends, in this video we will learn about freely falling objects. So let us say you are on the top of the building and you drop a ball. What happens to this ball? So once you drop this ball from the top of the building, it goes in the downward direction and finally come to the surface of earth. And why this happens? This happens because Earth has a tendency to pull everything towards its center, and we'll call a term gravity. So the pulling of everything towards the center, and for that I will use a word called gravity. So I can say basically this ball is falling under the constant gravity, and that's why this ball is going in the downward direction. So ball is falling under constant gravity. Now what will happen if I drop two balls? One is lighter ball, another is heavier ball. And this was an important question in the past years, and many philosophers has basically undertaken such kind of questions. So they pondered over these questions. So whether the heavy object will come first or lighter object will come first or both will come at same time, this kind of argument has been given in the literature in the past. Probably it was the Aristotle who was the first person or who was the first philosopher who said heavy object will come to the earth first. So heavy objects or heavy bodies fall faster than the light bodies in proportion to their weight. So he said if you have an object that is heavy, it will move with a fast rate. So its velocity will be fast and it will come to the surface of earth first, and then the lighter object will come. So this means earth has a tendency to pull the heavier objects with a greater rate and lighter objects with a smaller force. So it looks like the heavier object will take less amount of time to come to the earth's surface and lighter object will take more time to come to the surface of earth. But this philosophy did not lasted for a long time. Then Galileo came and he said a body or an object should fall with a downward acceleration that is constant and independent of weight. So he said if you have two objects with different masses or different weights, they will come to the earth's surface at same point of time. This means it does not matter what is their weight. Aristotle said it depends upon the weight. You have more weight, it will come faster. It will move faster, it will come to the earth's surface first. But the Galileo is basically saying reverse. He is saying no, it is not the case. All objects falls with a constant gravity, that is constant acceleration, and they all come to the same time on the earth's surface. Now the science and experiment has basically proved this, that Galileo was right at that point of time, that all objects move with a constant acceleration, that is gravity, and they all will come to the earth's surface at same point of time. This is a proven fact, and this can also be proved by some experimental observation that can be done in the lab. Remember, this is true only for constant gravity case, that is constant acceleration case, and this only happens if you are near to the earth's surface. If you are very far away from the earth's surface, you don't have constant acceleration. So constant acceleration happens if you are close to the earth's surface. For example, this is the earth, and let's say if you drop some ball from this height is h, and this is the radius of earth. Now if this height h is much less than the radius of earth, what is the radius of earth? This is around 6400 kilometer. This means if you drop a ball, let's say 100 meter, 50 meter, 500 meter, or at max you have some kind of activity on the earth's surface that goes up to 1 kilometer. In that case I can say h is in fact much less than r, and then I will assume the gravity is constant. So in this case, g value, that is gravity, that is basically constant. Now as you increase the height, this means as you drop a ball from much height, or in other words, if you do some kind of activity on the earth's surface that is not in the range of 1 kilometer, that is far away from the surface of earth. So this is the point, and there you are basically dropping a ball from this side or some other kind of activity, satellite or something like that. This height, let's say this height is h, and this height is comparable to radius of earth. So this height is approximately same as, or I can say h is not much less than, h is less than r. In that case, I cannot assume that gravity is constant. So this height can be, let's say 3 kilometer or 10 kilometer or 100 kilometer. In that case, if h is 100 kilometer, r is basically 6400 kilometer. So this distance is comparable. So if the distances and h and r is comparable, then I can say gravity is not constant. So g in this case is not constant. So you remember when we say that the object will fall with constant gravity and they will come to the surface of earth at the same point of time, this is true only if you are basically dropping a ball at relatively a smaller height that is not comparable to the radius of earth, that is much less than the radius of earth, and we also ignoring the effect of rotation of earth. So in this video or in this chapter, we will ignore the rotation of earth. So basically earth is also revolving. So this also causes, or this also affects the motion, something that is falling on the earth's surface. So we are ignoring the earth rotation. So if the distance of ball is small, that is this thing, compared to the radius of the earth. So radius of earth is this, that is 6400 kilometer, and if we ignore the small effect due to earth rotation, the acceleration is constant. So when we can assume that acceleration is constant, we have to satisfy two conditions. The first condition is h is much less than r. And the second condition is we have to ignore the rotation of earth. So if we ignore this fact, then I can assume g is constant. But if I have to account for large height and rotation of earth, in that case I cannot assume that gravity is constant. So g value will be different, and it will be a function of height. So if you are at this height, you will have different g. At this height, different g. At this side, different g. At this side, different g. So basically earth will apply different amount of force depending upon your location. If the height is much larger, or you can say height is comparable to the radius of the earth. So we will make these idealization or these assumption for further treatment of the subject. So if I want to simplify the problem, we will assume that gravity is constant and we will ignore the rotation of earth. So the idealized motion that results under all these assumptions is called free fall. So what are the assumptions? First is the motion is happening close to the surface of earth, and also we are ignoring the earth rotation. So these are the assumptions. So if we assume this, then I have idealized motion, and of course we are also neglecting the air pressure or air resistance. So air also has a resistance to the objects. So we are ignoring any kind of air resistance. That is another assumption. In that case, the idealized motion is called free fall, although it includes rising as well as falling motion. So when we throw a ball from top, this is a fall, but if I basically throw in the upward direction, that is basically rising of the ball. So when we say free fall, this includes both. Either you are throwing up or you are throwing down. So free fall is a relatively general term, and it includes rising as well as falling motion of the ball. Now let us try to look closely the experiment in the opening of this video. That is, you are dropping a ball from the height top of the building. So let's say at t is equals to 0, you just drop this ball. So this starts going in the downward direction. And what you are doing is, you are taking a snapshot, or you are taking basically photo of the falling ball at equal amount of time. So this means you are basically clicking your camera and you are taking photographs. So these snaps are taken at different times. So this is time t1, this snaps is time t2, t3, t4, t5. So what we are saying, these all snaps are taken equal interval of time. For example, this is taken at 0.1 second, this is at 0.2 second, this is at 0.3 second, and this is 0.4 second, and this is 0.5 second. Similarly, you have the photographs for different time intervals, and in each case the time interval between two snapshots is 0.1 second. So you see, the time interval in each case is 0.1 second. Now if you look closely, one important point, then each a small time interval, the distance traveled is not same. In this case, only this much is the distance. In this case, there is a larger distance, and in this case even more. So the distance traveled between two successive flashes. Time is same, delta t is same for all the flashes, but delta x, or you can say delta y, that is the difference between height, is not same. Delta y is increasing. Here you have larger distance and here you have a smaller distance. So as the ball is going in the downward direction, delta y is increasing. What that means? If you remember, what is the velocity? Velocity is nothing but delta x. If I talk in terms of average velocity is delta x, or in this case delta y, divided by delta t. So as delta y is increasing with time, I can say average velocity is increasing with time. So here I have a small average velocity and here I have larger average velocity. I can say average velocity has increased at this point of time. So average velocity is increasing. This means acceleration is also, this means we have an accelerated system. So there is acceleration. So velocity is changing. If velocity is changing, then we can calculate acceleration. If you remember, we have formula for average acceleration. This is nothing but change in velocity divided by change in time. That is time interval. And these all are vector quantities. So now velocity is changing. So delta v, velocity is changing. I have a different average velocity at this point and different average velocity at this point. This means I can calculate v2 minus v1 divided by t2 minus t1. So there we have average velocity v1 and here I have average velocity v2. Then I can write v2 minus v1 divided by t2 minus t1, that is delta t, and that is your average acceleration. Now from experiment, it is found that this average acceleration remains constant. So if you drop a ball and you basically measure the height of the ball at different instant of time, and you can calculate average velocity and you calculate the average acceleration, then you will find the acceleration value remains constant. What this means? This means you can calculate average acceleration using these 2 points, you can calculate average acceleration using these 2 points, or you can calculate average acceleration using these 2 points. How will you calculate? You know velocity at this point v1, velocity at this point v2, so I will take v2 minus v1 divided by delta t. Here also you know the velocity v1, you know the velocity v2, v2 minus v1 divided by delta t, that will give you the acceleration. So we found that acceleration between these 2 points, acceleration between these 2 points and acceleration between these 2 points always comes to the same value. This means acceleration remains constant, and we call this acceleration as a gravity, acceleration due to gravity. So acceleration due to gravity is constant. So I can summarize this experiment. So in this experiment you will find equal time interval between flashes. So what we have done is we have considered time interval between two flashes is same. So when we are clicking first and the second, the difference between time interval between any two consecutive flashes is same. And what is the result? Increasing distances between images so that the velocity is continuously changing and the ball is accelerating. So from this figure we find that the distances between two successive time intervals is increasing. So this means ball is accelerating in the downward direction, and we found this acceleration value is a constant value, and we call this as a acceleration due to gravity, and simply we denote by z. And remember, this gravity is acting in the downward direction. So it is possible to measure the acceleration due to gravity using such experiment. So we have done a very simple experiment, and using this experiment you can measure the acceleration due to gravity. There are more sophisticated experiments that is also possible, and from those experiments you can measure the z. And if you perform this experiment, you will find z value is 9.8 meter per second square. So z is acceleration. So unit of this will be meter per second square. And what is the value? In SI unit, the value is 9.8 meter per second square. Or the same you can say 980 centimeter per second square, or you can say 32 feet per second square. So this is a approximate value if we are close to the surface of Earth. If you go very far away from the surface of Earth, this value will not remain same. This value will be different. Basically, as you go up from the surface of Earth, this g value decreases. Now the concept of gravity is not only true for Earth, it is also true for other satellites. For example, if you go into the moon has a tendency to pull the things towards its center. Then we will call this is the gravity due to moon. And if you go to the sun, you will call gravity due to sun. So the value of z depends upon location, where you are. You are either on the moon, or you are on the sun, or you are on the earth. So if you are on the moon, the z value is very small, that is 1.6 meter per second square. And on the sun, this value is very large, that is 270 meter per second square. This means sun has a more tendency or higher pull forces to pull some things towards the center of the earth, center of the sun. The magnitude of z is always taken positive. So you see, the z is always acting towards the center. So we'll assume that this is a positive, and sign we will see that will come from the coordinate axis. So if I am choosing my coordinate axis is in the upward direction, if I am choosing my coordinate axis is in the upward direction, that is positive y-axis is in the upward direction. So gravity is acting in the downward direction. So in that case I will say the gravity is z, magnitude is z, but the sign is in the downward direction. So I will put a negative sign here. Now I will illustrate whatever we discussed here using a problem. So this problem says a 1 rupees coin is dropped from the Leaning Tower of Pisa and Philip falls from rest. What are its position and velocity after time of 1 second, 2 seconds and 3 seconds? So the first thing is, you see in this problem there is a word called free fall. So what is the meaning of free fall? So when we say free fall, this means this is moving with constant acceleration. So this is moving with constant acceleration. and this constant acceleration value is simply z, and that is acting in the downward direction. Now if you remember, in the previous chapter we derived few formulas, that is constant acceleration case. So you can basically calculate distance, velocity, if you know that this acceleration is a constant acceleration. So if you remember, for constant acceleration we have formulas, that is one dimensional motion equations, that is s is equals to ut plus half at square, and v is equals to u plus at, and v square is equals to u square plus 2as. So these are the three kinematical basic equations that we developed in the previous chapter, that works only if acceleration is constant. So in this case, constant acceleration is constant, then only these formula work. Now this problem is a free fall. This means acceleration is constant and the constant acceleration value is z. So now I can apply this formula. That is the advantage. So what are the things that we have to find? We have to find position. So we have to find position. And then we have to find velocity. And this we have to find as a function of time, that is a different point of time. So now how will you solve this problem? An initial velocity is 0 because this has given that this has been simply dropped. This means you are not throwing in the downward direction, you are simply dropping. So if you are simply dropping, this means initial velocity is 0. To solve this problem, first I have to set a coordinate system. So initially my coin is somewhere here. So this is the position of the coin. Now this coin has been dropped in the downward direction. So generally we put our origin of the coordinate system from where the motion starts, from where the ball has been dropped, or from where the coin has been dropped. So this will be my origin. So this point is origin. So generally we denote word O, this means origin. Now generally the y-axis is taken in the upward direction. So this is my y-axis, that is positive direction. So this point is origin, and this y-direction, that is y-axis, is in the upward direction. And since this motion is along a straight line, I need only one coordinate system, only the y-coordinate system. So let us try to find what is the acceleration. Once again, acceleration will only be in the downward direction, and the value of this acceleration is z, but this is acting in the downward direction. My positive direction is in the upward direction, so I have to put a value of minus. So negative z is the acceleration. What is the initial velocity of coin? So coin has simply been dropped, so I can write uy is equals to 0. That is, initial velocity in the y direction is 0. Now I can use this formula to find displacement and velocity. So what is my target value? My target is to find what is the position, what is the velocity. So at certain point of time, so let's say this is falling in the downward direction, and at certain point of time this coin is here. So this is the position of coin at certain point of time. So this height, that is this height, is y. So we have to find what is this height y, and also we have to find what is the velocity at this point of time. So with what velocity this coin is moving in the downward direction. So let us write s is equals to ut plus half at square formula for this motion. So what is the distance? Distance is y. So this s. What is the initial velocity? That is ut plus half at square, and since I am talking about the y-axis, I can put a subscript y. So what is the initial velocity in the y direction? 0. So half, what is the acceleration? Acceleration is simply minus g t square. So now I can write y is equals to minus half gt square, and g is nothing but 9.8 meter per second square, and this is t square. So this becomes minus 4.9 meter per second square t square. So this is my y value. Similarly, I can write velocity in the y direction, that is u plus at, and I have to plug the subscript because I am considering motion in the y direction. So what is the initial velocity in the y direction? Initial velocity is 0 and acceleration in the y direction is minus g and time t. So this becomes minus 9.8 meter per second square time. So this is nothing but minus 9.8 meter per second square t. So this is the expression for velocity. So now I know position and velocity as a function of time. So in the problem it is said we have to find y value for t is equals to 1 second, t is equals to 2 second and t is equals to 3 second. So let us try to find for t is equals to 1 second. So I can calculate y value for t is equals to 1 second. What I have to do? I have to simply plug t is equals to 1 in this expression. So let us find this value. So y is equals to minus 4.9 meter per second square t square. So I have to plug 1 in place of t. So this will be 1 second whole square. So this will be nothing but minus 4.9 meter. Similarly, I can calculate Vy, and the expression for Vy is nothing but minus 9.8 meter per second square, and this multiplied by time. So in this case time is 1 second. So minus 9.8 meter per second square multiplied by 1 second. So if you calculate this will come minus 9.8 meter per second. So we calculated the position and velocity at 1 second. Now similarly I can calculate for t is equals to 2 second and t is equals to 3 second. So if you do this, for t is equals to 2 second, you will find y is equals to minus 20 meter and velocity in the y direction, that is Vy, that you will find that is coming minus 20 meter per second. And for t is equals to 3 second, you will find the y value is minus 44 meter and the velocity is minus 29 meter per second. So you see one important point, the y in all cases is negative. So y is minus 20, minus 44, minus 4.9. So this also means the y is opposite to the axis. So y axis is in the upward direction. So you will have somewhere here, that is 4.9, 20 somewhere here, and this is minus 44 somewhere here. So y is opposite side to the origin, that is opposite side to the y axis. That's why y we are getting is negative. Also the velocities are negative. This means velocity negative means this is acting in the downward direction. So my velocity is in the downward direction. Since I have chosen my axis, positive axis, in the upward direction, velocity is acting in the downward direction. So in this video we learned about free fall objects, freely falling objects. In that case, how do you calculate different instant of time, what is the velocity, what is the distance of the object, and you can use constant acceleration formula for solving such problems. And whatever the theory we discussed, that basically makes some assumption. One assumption is your ball is not very far away from the surface of earth. Another is earth rotation has been neglected, and we have also assumed air resistance are not that much. So we are ignoring the air resistance. So if you use all this idealization, we can make a model or we can make a theory for freely falling objects based upon the constant acceleration case. And this constant acceleration is nothing but gravity. And once I know the value of gravity, I can calculate displacement, velocity at different instant of time. I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.